welcome. We'll get started so we can get you out of here soon. You know, we're between you and drinks, and we'll make it as entertaining as possible. My name is Sudhakar, and I have my colleagues, Professor Kurt Collins and Dr. Yunfei Ho, joining us in this presentation. So we're from Cal State San Bernardino. I'm the CIO there, and both Kurt and Yunfei are professors. So we started this project about a year ago, and it was we launched a program called the Bright Minds Internship Program. We had the partnership with the Pacific Research Platform. We had 100 gig connectivity to our campus core, and we were trying to find some science drivers to use the network to advance their advanced research. So we looked at projects across the campus. There were multiple projects that we could attack. So we wanted to narrow it down to one project that we can all handle and show reasonable progress and productivity, so we can use other faculty members to advance their projects as well. So we developed this internship program called Bright Minds Internship Program. It's a year-long internship for undergraduate students, and it's an interdisciplinary research community of faculty, students, and staff. Now, we wanted to look at projects of high practical impact for the campus and projects that advance one of our strategic goals. We are, as if you didn't know, that CSU is going through a GI 2025 initiative where we want to increase the percentage of 4-year and 6-year graduates. And then we're going through a quarter to semester conversion and also university strategic plan. And we had a pilot project called Ambrosia that we started 3 years ago with a geology professor or an anthropology professor. And the project really bloomed into a multidisciplinary project involving faculty, staff, and students from different disciplines, computer science and English and theater and drama and those disciplines. So we wanted to build on the Ambrosia project and launch another project that's multidisciplinary using the PRP resources and the CENIC resource that we have on campus. So this is the research community, which is faculty and staff from computer science and academic technologies, the University Honors Program, Office of Student Research, and the Pacific Research Platform. So I'll turn it over to Kurt.
Hi, I'm Kurt Collins. I'm a professor on this project. Our first question when we started this out was to really kind of frame the problem. And as it turns out, we really don't have a problem, but we'll get into that. We have, right now, we're currently at around 23,000 and change on campus. We have just over 1,000 faculty members and 1,200 staff members. The parking spaces available for students are 7,300, and faculty spaces are about 683. So that puts us at right around 8,000 slots. The density of students on campus at the highest point during the day is about 5,000 students enrolled in classes. Now, there's always a fudge factor. Students come early, stay late. So, but for the most part, we're pretty much at capacity. The problem that we have is that the students don't seem to be able to find the spaces. So we have tried to keep up with with students needing parking spaces. The campus was founded in '65. In the last about 15 years, we're growing at a rate of about 2.5% a year, and 3,000 spaces have been added to the campus in the last 10 years. The problem that we have with the campus is that the campus is situated at the northern face of the San Bernardino Mountains. So the only access to the campus is through the south side. We have a main access along University Parkway that comes in from the 215 highway And most student and most traffic on the campus come in that way. We also have alternate access to the campus at either end, but those are very, very lightly used, especially by students, but really for all faculty. The campus has a ring road that goes around it. And so in order to kind of give an idea of where we're at, I've got a map here, and you're going to see just a little bit of an animation. So that main 2-lane road that you see coming in there, that's University Parkway. That leads into the front of the campus. The 2 lots that are most heavily used and where students report having a little space available is to the left of the main entry, which is Lot C, and to the right of the main entry, which is Lot D. Two lanes from the access road, the main access road, lead right into the campus. So everyone just follows the traffic and leads right into campus. Whereas if the students would turn left or right and go to the outbound ring road, they would find probably another 3,000 to 4,000 parking spaces. But let's see here. How do we get this animation to work here? Just click on it. Okay. Now what? Oh, thank you. So being the faculty designer in charge of 3D, I had to do something on this. So this is how our traffic goes, and you can see that when the animation runs, the first 2 lots to fill up when the traffic shows up here are the front 2 lots because they're the easiest to get to. If you were to go all the way around, you can see that the other students are already out of their car. The ironic thing about it is that the front 2 parking lots are generally the farthest away from any type of academic building. So that's kind of the framework of our problem, and Dr. Howe will take over and discuss our solutions. Thank you.
Well, hello. I'm going to tell you a little bit more on the details on our parking monitoring projects. Well, actually contradicts for what Kurt just said about the number of available parking space and the student parking. This parking problem is actually a reoccurring theme from our school's newspaper, and you probably can guess what they're complaining about. There's not enough parking space, there's too expensive parking tickets, and so on and so forth. Personally, my frustration is that sometimes when you see there's a parking space from afar, when you approach it, you realize this is actually a very small car that's taking the entire parking space. So for those of you driving a very sustainable vehicle, please line up by the rear of your car, not the front of it. Well, on the other hand, from our parking services, there indeed have a surplus of parking spaces. So the challenge for this project is really how can we provide better guidance for our students to reduce number of circling in the parking structures as well as the idling part. So about these projects, our objective is to provide real-time information on the number of available parking spots in one of our parking structures. And we really want to start with a very simple setting. We're going to merely counting how many cars are coming in and getting out of the parking structure. And we choose this parking structure as a pilot study in part because we really have very simple traffic. This parking structure has 2 entrances, is fully covered with our Wi-Fi, and we already have several surveillance cameras being installed inside the parking structure. Well, we have set a few objectives for this parking monitoring projects. Firstly, we want to have this with a high accuracy on how many cars are in our parking structure. And we're going to do this by combining the camera recordings from our surveillance cameras with a little bit help from the computer vision to count how many cars has been captured by our surveillance camera. At the same time, we're planning to install a few of those IoT sensors. Those are the loop detectors under the pavement to really track how many cars are at the gate. Our second objective is to install this system at a lower cost. Our current budgets provided by our generous VP and ITS is about $10K for the equipment. Finally, we want this to be a project-based learning project. In other words, we want to combine these projects with the undergraduate coursework. Well, we hope that this will be an interesting project that our students can take on. And we think this task and these topics are particularly suited for our graduate students for their capstone courses. For example, in computer engineering, we usually have an engineering capstone course, ask the students to work on a project that at the end of the year, they can deliver a product. And we think this parking monitor would really be one of those interesting projects that students will be interested in participating and make an impact of their campus life. So for this parking structure, as shown in this slides, this is a 3-level parking structure with a total number of parking stalls of about 745. Well, if you hire a contractor to do a parking monitoring system for a parking lot in this scale, it usually will cost you about $0.5 to $1 million. Well, this is the system we're talking about. They have the guidance for each and every parking spots. You see a sensor under each of those parking locations, and there's probably a light or an indicator on the top to tell you where are the available spots. So instead of those more fancier, more complex system, we're really looking at a more simple version and at a lower cost. We'll think about the cost of building a parking structure. Well, the parking structure we have here for each of those parking spots is cost about $14,000 to build one of them. The total cost for this parking structure is $20 million. And that was in 2008. If you're looking at a similar structure nowadays, each of those parking spaces will cost you about $20,000 to $30,000. So coming back to the cost of our projects in terms of monitoring, we're really looking at a low-cost, highly efficient system. And during our literature review, we believe that providing a low-cost parking service can be a good idea for startup business. There's really having a gap between those high-end parking monitoring system versus a relatively simple or low-cost solutions. And in our opinion, this would be a worthwhile for a startup entrepreneur type of opportunity. So coming back to our system, there are 3 major components. We're going to start it with a computer vision-based vehicle counter. This is utilizing our existing infrastructure, those civilian cameras we have inside our parking structures. Those civilian cameras in our parking structures are actually pretty advanced system. Those are high-definition 2K cameras. We have a total of 13 cameras in each of our parking structures. And 2 of them, or actually 3 of them, are parking directly in front of the entrances. And for our backend service, our police department have a recording of 3 months of those high-resolution video recordings in the parking structure. So that's the part 1 of the project. The second part of this project, we really want to bring in some of those IoT or Internet of Things sensors. And those are the wireless induction loops that can be buried under the pavement. And this is a long-established research. We have been using those loop detectors for intersection controlling for quite a long time. So one of the ideas we have is really bring those systems as well into our parking structures to providing a more efficient system. And the final piece of our system is, of course, a web application for parking monitoring to better inform our students, and maybe at some locations to have a message board to tell students how many available parking spaces are there. Well, I want to put down or having a less emphasis on the application development. The major efforts in this project will be really providing a more reliable and accurate system. I would say the web application development is probably just 20% of the overall effort. It's more about design a system that is accurate and reliable, also requires minimum maintenance for the purpose of counting the number of vehicles in the parking structure. Well, here's a closer look on the sensors we have. This is some of those off-the-shelf induction sensors. They are mainly used to monitoring traffic flows near the intersections. Well, the one we have come from the Senses networks. They are actually pretty high accuracy magnetic sensors. They are capable of identifying bicycles and motorcycles. And at the same time, they also offer a high frequencies on the data rate. They have a sampling rate of 128 hertz. Those are used for tracking the vehicle speed. If you have two sensors being buried in the same direction or down the lane, you'll be able to, well, count how long it takes for triggering both of sensors, then infer the speed of the vehicle. Those sensors are built on well-established IoT systems. They're operating on this IEEE 802.14 protocol, which is one of those low-rate sensor network type of systems. Each of those sensors costs about $500. The last two features of the sensors, I would say, well, in my opinion, is a little bit optimistic. They claim to have a wireless communication range up to 1,000 feet, but those are the loop detectors buried on the ground. So I would say because of the ground effect, their communication range is probably in the range of maybe 100 feet or 30 meters tops. They also have the feature of self-powered batteries, and they claim they have a battery life for 10 years. Well, in my opinion, this is again kind of optimistic given this direct sunlight and this significant temperature shifts in our San Bernardino region. But luckily, this comes with a 5-year warranties, so hopefully they'll last. Well, here's another closer look on the sensor. This is a 4-inch in diameter. You just need to dig a hole on your ground. They're battery powered, so you just need to bury them in, fill up with some epoxies. This is some kind of gel, and they'll start working. Well, the second part of our project is using computer vision to extract how many vehicles are there identified from our cameras. And here's one of the cameras we can see from the east entrance of the infrastructure. Well, we're going to do 2 steps to count the vehicle. The first step is to identify the vehicle from the background. And this is achieved by looking at frames by frame where of those pictures have changed. Well, as you can see here, we can compare the changed portion and highlight it with a square. The second step in counting the vehicles is to track the movement of these vehicles. So after we extract them from the background, we track the center point of this highlighted region. And you can see that, well, looking at the movement of the center point, and we also highlight these two gates by red and green. So one is the exit, the other is entrance. By looking at the moving pattern or tracking the center point of this block, we'll be able to identify the moving directions and then infer how many vehicles are coming in and coming out the parking infrastructure. Well, here's a floor map of the entrances I just showed you. You can see that on the left, we have this nicely placed camera on the left. And we notice our sensor is actually being placed outside the parking structure. This is because the concrete inside our parking structure are post-tensioned. So it's not safe for you to drill holes on our concrete directly. Well, in addition to just identify the moving cars and track their motion, we can actually do a little bit more than that. Well, in this video, I'm showing you at another entrance, we're looking at identify the cars as well as pedestrians in our frame. We can do a little bit more features than just the cars and pedestrians. We can extract features such as the color of the car, the type of the car. At a later time, we might be able to specify what is the make, year, model of the cars. Well, this video also shows some of those implementing challenges for this computer vision project. For one thing, you probably can notice a larger portion of this video has been, it actually has been blocked by this pickup truck here. And at the same time, the moving behavior of those vehicles can be challenging, or they can confuse the algorithm. For example, this small car here is going to appear on the screen. They have taken a U-turn and stopped there. And this may confuse our algorithm in many ways. It seems that it's triggering this leaving events twice, but in fact, this car has been parked and not leaving there. So there's a few of those technical issues we need to look into when working on the video detections with computer vision based algorithms. Well, this is the floor plan for our other entrances, and you can see that the camera is actually on the side of these entrances. That's kind of lead to this largely blocked wheel. And we also run into problems when it comes to where can you put the receivers for your wireless sensors, and those create some wiring or other technical issues at the time of implementation. So this simple description of our problem actually hides various design challenges. Just to mention a few of them. Firstly, we have this challenge of miscount. This miscount comes from both the sensor errors, but also due to these complex behaviors of the travel patterns. Well, in those videos I show you, those are normal moving behaviors. We haven't really account for those traffic violation behaviors. Well, you'll be surprised how people drive their cars inside parking structures. Well, so to solve this problem of the miscount, we're looking at this data fusion technique. We're combining two of those video sources, one from our camera, the other from the sensors we have. At the same time, the other technical challenge we encountered is really the calibration and the accumulated error. Merely counting how many cars coming in and getting out of our parking structure is not enough to provide the parking monitoring. We need to know at the beginning of the time how many cars already inside our parking structure. So this is really the problem of when and how to reset the vehicle counters. Well, there are some straightforward solutions. For example, I can reset the vehicle counters to 0 in the middle of the night, let's say Sunday midnight. However, we probably can have more elegant solutions. For example, I mentioned we have 13 other cameras inside our parking structure. So if we can utilize those information, we can have a better estimation on the calibration and accumulate and handling the accumulated errors. Well, in addition to technical challenges, we also have some policy challenges. For example, privacy is a problem. Although we can extract more features from our camera feeds, like we can track the vehicles, we can track the pedestrians. At the same time, we also want to avoid misuse of those technologies and those information. Not to mention, those camera feeds are actually, the access to those camera feeds are restricted. They are controlled by our police department, and we have certain protocols for getting those information. Well, the next policy challenges we have is really on the maintenance aspects. We get great support from our ITS department and the police department, as well as our parking services. But we also want to think a little bit further advanced. After our pilot study, there will need further investment on the system monitoring, on the data storage, and we need to have a better plan on how can we keep up with the system. Well, finally, I want to mention a few of our next steps. As Sam mentioned, although we have a year-long, actually continues the third year on this Bright Mind internship program, this parking monitoring project is actually relatively young. We started this project this quarter, so we have precisely 9 weeks in this project. This is still a work in progress. We're looking on more the development parts of this. Another aspect we'd like to explore is to do parking prediction. And this is where we can really utilize the Pacific Research Platform, as well as this great infrastructure from the CENIC. Right now, we are merely counting how many cars are there in the parking structure. But it wouldn't be helpful if I'm driving my cars from home. I like to do a little bit prediction to see when I arrive on campus, what would be my best parking strategy. And to do that, we need to kind of study the historical data. And we have 3 months of historical data stored in our ITS infrastructure. Those are the camera feeds in the last 3 months. We really want to utilize the computational power for the Pacific Research Platform, as well as the high-speed connection to help us to process those data so that we can better infer, better predict the parking situation for our students. Of course, the future steps also includes we want to collaborate with more departments. This is really a project-based learning opportunity. We want to help our students to give them this opportunity to learn some hands-on experience on solving real-world problems. And of course, this is also looking at to prepare them to to better prepare our students to the workforce. And finally, when we have time and resource, we want to expand to more parking lots and study the moving behaviors of our students. Well, that actually concludes our presentation today. And thanks for your attention.
Anyone have any questions for any of us?
So one thing I was kind of curious about is for parking do you guys use a permit system or is it just effectively open?
Yeah, it is a permit system.
Okay.
Yeah.
So I'm from Stanford, where we have just tremendous, recurring parking issues where it's just finding parking in general. Especially when construction happens and that knocks out a parking lot. One of the things we did recently is parking and transportation that handles permit administration and partial enforcement. They're actually moving off campus. And as a side effect of that, they switched from actual permit decals to an online system where you purchase the permit, you link your vehicle license plate and description to that, and they have outfitted all of their pickup trucks with license plate recognition systems. If you guys ever consider that, the side effect would be that would actually get you a fairly accurate vehicle count because they're just driving through all of the garages all of the time every day. The other thing, again, since we're in a constrained parking environment, is event parking. We have one parking lot and one floor of one parking garage that's reserved for event parking. And both of those are an annoying walking distance away from the actual places where events typically happen. So it would be nice, and those are reservable, but it would be nice, especially depending on the time of an event, to be able to say with actual data, oh, we can park over here and it won't be a problem because this data and these predictions show there won't be any impact on the existing population. So having that, it would be actually pretty cool.
We have, I think I'm on, am I on here? Yeah, we have some pretty accurate data as far as where the students that are coming in, because we're essentially a commuter campus. So we have pretty accurate data where the students are taking their classes, and we would be able to accurately send them to a parking lot that would be closest to where their classroom is. Students get in the habit of parking in a particular spot, and I think that happens the first year they come. So it doesn't really matter how far away it is from that parking spot, they always park there. So there's those challenges. The other thing that's probably slightly different about our campus is, yes, the parking is by permit, but the students are able to buy those permits on a daily basis. So their license plate isn't actually linked to the permit, and their permit, and I would say some 80% of our students do not buy a quarterly or an annual permit. They just buy daily permits. So that adds to our challenge.
Hi, I'm Celeste from USC. I may have missed this, but have you looked at any of the commercial packages and what approaches they took? Because there's places like the Portland Airport where it tells you exactly what row you can go down and how many spaces are available. And then there's other apps that can kind of direct you. I know the city of Santa Monica, you go in and it says there are no spaces available, so people can just bypass the parking. So I'm just wondering if you've looked at those.
Oh, yes, indeed. We actually look into we conducted a literature review on those parking monitoring business. And we concluded that, well, this in part, it will cost us a lot of money to implement those in our parking structures. Two is that, well, it wouldn't be that interesting. We can combine this as a student project. Well, parking monitoring is not a new problem, and there's a lot of solutions. But this is well inside the skill set of our students. So we want to really make this a project-based learning opportunity, not only to solve a problem on our campus, but also provide students with this opportunity.
Plus, it's less expensive.
Actually, that's my question, is about the kind of student engagement side of this. Can you say a little bit more about how many students you might involve? Would they be students you hire? Would this be part of their coursework? Those kind of questions.
Oh, of course. Well, I'm in the Department of Computer Science and Engineering, and this is definitely an engineering project. We link this, in my course, this will be a group projects. There are 2 groups of students working on this right now, with a total of 10 undergraduate students. I would expect this will be a continuous project. In part is that we're still on the exploratory stage. Many of those details on this project we haven't figured out. At the same time, we have quite a few parking lots. If you're looking at our campus map, we're actually surrounded by parking lots. So there's, I would say there's more opportunities, at least for our engineer students to explore.
Anybody else on this side?
Michal Garcia, for storing the historical data, have you been thinking about just storing metadata, not recordings? It helps with, let's say, privacy and safe space and other stuff.
Well, at this stage, we actually loved our raw data because we're still exploring different algorithms to do the computer vision processing, do the data fusion. And I can see that maybe at a later time, we're going to have a more aggregated data being stored. But at this point, since we're still researching on this issue, we enjoyed storing all of our raw data so that we can access more resources from our ITS.
I'm actually kind of curious now, especially as an undergraduate project, what's the plan right now of ensuring, well, number one, ensuring that the system keeps on working and is maintained over the summer, and then assuming a standard quarter semester system, and then handling it long term, since systems age out, APIs change, technology has to be refreshed. Is that something that's being planned into the curriculum right now for future classes?
So it's as I mentioned in my slides, it's a faculty, staff, and student project. So there are permanent staff who are involved in this project as well. So once the project becomes operationalized, we'll pass it along to the parking folks who are also involved in the project.
Any other questions? Thank you.
Thank you.